Welcome everybody to Factoring and Applications Lesson 4. So last lesson we looked at factoring by decomposition, and we've also looked at factoring trinomials through inspection. And we're going to put these skills to use in this lesson here. So I know that you're used to looking at trinomials that are ax squared plus bx plus c. But now we're going to start looking at functions or trinomials where that x term is actually a function. So you have a multiplied by f of x squared plus b multiplied by f of x plus c. So what we've done is we've replaced those x terms with actual functions that aren't x. So we're going to start by looking at functions that are monomials or one term. I'm going to skip all of this, but I'm going to show you something quickly. You can see in this one right here, we have x to the power of 4 plus 5x squared plus 6. So that breaks our usual mold of x squared plus x plus constant. But you can actually imagine this x to the power of 4 as, or not imagine, but rewrite it as x squared all squared. And then where you can group that x squared or put brackets around it. And then what they do is they say, well, let's make capital A is equal to x squared. You can use any letter you want. It doesn't matter. It's just a bit of a placeholder. No worries. So what you can do now is sub capital A in anywhere that you see an x squared into that term. And so what you end up getting is a squared plus 5a plus 6. And we can factor that pretty nicely by inspection into a plus 2, a plus 3. And then what you can do is just, once you get this answer, plug your x value, your x squared, a is equal to x squared, so now we can plug that x squared back in, and we get these answers right here, x squared plus 2 times x squared plus 3. So we've factored it by inspection, which is always nice to do. We don't have to do decomposition, but we had x4 and x squared, so it's a good little trick. So we can do the same thing here with some examples. So we'll do example A. So it says here we have a to the power of 4 minus 5a squared minus 14. So we can say let capital A equal a squared. And now I can rewrite this trinomial as a squared minus 5a minus 14. Hopefully that makes sense. This a to the power of 4 got rewritten as a squared to the power of 2. So then I change this part into a capital A, and then it makes a squared. And now we can factor by inspection. We need two numbers that multiply to negative 14, add to positive 5. So we can do our little multiplication chart here. Negative 1 times 14, 1 times negative 14, negative 2 times 5, 2 times negative 5. And right there is not the right answer. Sorry, got ahead of myself. And then you can say, that's because 2 times 5 doesn't equal 14. End of the day, trying to do videos. Negative 2 times 7 and 2 times negative 7. So right here, you can see 2 times negative 7. When we add that, we get negative 5. So now we can say that the answer is going to be capital A plus 2, capital A minus 7. And we're not quite done, because now we want to revert this answer back to our small a, because that's what we started with. So we know a is equal to a squared, so I can just sub that back in right there and right here. And there we go. That is our answer. Same thing with this one. I mean, you can use any letter that you want. Capital A, you can use capital k if you want. I'm going to say capital K is equal to x squared. So now I can rewrite this as k squared plus 4k minus 5. We can do our inspection. The reason that we can do inspection is because there's no constant in front of our k squared term. So I'm looking for two numbers that multiply to -5 and add to +4. Well, if we're multiplying to -5, we can do 1 and -5, and that actually does not add. It's -1 and +5. So -1 plus 5 gets us +4, and when we multiply that, we get -5. So now we can make our answer k minus 1, k plus 5, and then last step is to substitute our x squared back in where we see k. So now we can say x squared minus 1 and x squared plus 5. So that's kind of the idea behind this unit, is subbing, or like creating this variable here that we can sub in for x squared or a squared, solving our problem, and then rewriting it in terms of x squared. So now we're going to look at a couple of different methods that you can use to solve this. So method 1 shows us, we have this problem here, 4y squared minus 11y minus 3. So we're going to use that same one in both. And you can see that we have a coefficient in front of our leading term. So that means we're going to have to use decomposition. So you can use decomposition two different ways. You can do what we've been doing before and say, okay, well, we're going to let capital A equal y squared. So now I can rewrite this as 4a squared minus 11a minus 3. And now, just like we learned with decomp, I'm going to take 4 multiplied by -3, and I get -12. And then I'm looking for two numbers that multiply to -12 and add to -11. So what we can do is go 1 times -12, -1 times 12. It looks like we already found it right in the top there, because 1 plus -12 is -11. So what you can do is split this -11a. So we have 4a squared. Now we're going to split that -11a into -12a plus a, or 1a minus 3. And then we are going to do our grouping. So we're going to group the first two and the last two and pull out a common factor from each of them. So the first one, I can pull out a 4a, and I'm left with a minus 3. And in the second one, I can pull out +1. Can't really factor anything out, so you factor +1 out, and you're left with a minus 3. And you can see that your binomials match, which is awesome. So you can rewrite that as, I'll write it over here, a minus 3 and 4a plus 1. Because we're not quite done yet. We know that capital A equals y squared. That's what we set up at the start of this problem. So the actual answer is we're going to put y squared back where we see any a value. So now we have y squared minus 3 and 4y squared plus 1. And that's our final answer there. The other way to do it, I think this way is awesome. I think it'll work every time, and so will the other one. But this one, it just keeps with the theme of using, like, creating a new variable, putting it in, and then subbing it out. In the next one, we're looking at just knowing that, if you have x squared, x constant, that decomposition is going to work if you have x to the power of 4 x to the power of 2 constant. Decomp is going to work. You need that descending order, like squared 1, 0, fourth squared 0, or even x to the power of 6, x to the power of 3 constant will work. So you can actually just keep it the way that it is. So what we've done is, or what they've done here, they did the same thing. They took 4 multiplied by -3, and they got -12. They did their multiplication chart, so -1 and 12, two numbers that multiply to -12 and add to -11, and they ended up splitting that -11y squared into -12y squared positive 1y squared. And so instead of subbing in a capital A, they've just kept it as y to the power of 4 and y to the power of 2. Because you know that this is going to work if you do 4, 2 constant. And now what you can do is we can do our grouping. So we group 4 y to the power of 4 minus 12y and positive 1y squared minus 3. And we're going to factor out the greatest common factor that we can. So in the first bracket, I can factor out a 4y squared. And what I'm left with is y squared minus 3. And in the second one, I can factor out a positive 1. And I'm left with y squared minus 3. And you can see that your binomials here match, so you're on the right track. So when we factor that out, I did this backwards, but we have 4y squared plus 1 and y squared minus 3. And you can see that it's the same answer. The reason I like the substitution one better is because when you start getting into tougher problems, especially using like sine and cos and things like that, or binomials where, this function here is no longer a monomial, it's going to get really hard to just split it like that. So it's good to be able to sub in a value, do your decomp, and put it back into the equation. Okay, I'm going to do all 3 of these because I don't know why. Probably it's good for you to see all of them. So here we have x to the power of 4, x to the power of 2 constant. So what you can do is that if you have 4, 2, 0, this is going to work. So I have 4x to the power of 4 and -6, but I want to split my -5x squared into 2 terms. And so I can figure that out by going 4 multiplied by -6 is -24. So I'm looking for 2 numbers that multiply to -24 and add to -5. So you can do 124 plus or minus, 212 plus or minus, 38 plus or minus, which actually would work. So if we're looking for -5, so if we do +3, -8, that would work. So let's do -8x squared plus 3x squared. Now we can do our grouping. And that's supposed to be a plus right there. And then we can factor out. So in the first bracket, we can factor out a 4x squared, and we're left with x squared minus 2. And in the second bracket, I can factor out a plus 3, and I'm left with x squared minus 2. I know that that's the right answer because my binomials match. So I have 4x plus 3, x squared minus 2 as my answer. In the next one, I'm going to use my substitution method. So I can say AB is equal to, let's use capital Q just for fun. So that means if AB is equal to Q, that means A squared B squared is equal to Q squared, right? So I can rewrite this as 2Q squared minus 31Q plus 99. So I am going to do 2 multiplied by 99, and I get 198. So I'm looking for two numbers that multiply to 198 and add to 31, to add to negative 31, sorry. Instead of going through my whole multiplication chart, which you might end up having to do, what I'm going to do is just tell you the answer just to save time. So we're going to get negative 22 and negative 9. So negative 22 times negative 29 gives me positive 198, and negative 22 plus negative 9 gets me negative 31. So that means I can split this negative 31 term into negative 22q minus 9q plus 99. Now I can group and I can factor. So in the first one, I can factor out a 2q, and I'm left with q minus 11. And in the second one, I can factor out a negative 9, and I'm left with positive q minus 11. The signs change when you factor a negative number out, and our answer is going to be 2q minus 9 and q minus 11. Those are our two factors, and we have to sub in AB into both of those because we know Q is equal to AB, so our real answer is going to be 2AB minus 9 and AB minus 11. And that's the answer right there. Okay, I'm going to do the next one. I know we've got three more examples to do, and then we're done. Okay, so same process with this one. I've got x to the power of 4, x to the power of 2, and constant, so I'm not going to do my substitution method, even though I love it so much. So we're going to go 8 multiplied by negative 3, and we get negative 24. So I'm looking for two numbers that multiply to negative 24 and add to 10. So 124, positive, negative, 2, 12. Oh, that might work. Positive 2, negative 12, or positive 12, negative 2. That's it right there. Positive 2, or negative 2, positive 12, when I add them together, it gets positive 10. So now I can rewrite this as 8x to the 4th. I'm going to split this term into negative 2x squared plus 12x squared minus 3. I can do my grouping now, and I can factor things out. So in this one, I can factor out a 2x squared, and I'm left with 4x squared minus 1. And in the second one, I can factor out a 3. So I'll pull out a positive 3, and I'm left with 4x squared minus 1. So my factors now are 2x squared plus 3 and 4x squared minus 1. So we're not actually done yet, and there's a reason I wanted to do this one, even though it looked very similar to the last two examples. But if you look at this term right here, you notice that we have a perfect square in 4x squared, a subtraction sign, and a perfect square in 1. So this is actually a difference of perfect squares, or a difference of squares. And because it's an x squared, so because it's all a difference of squares, we can actually take that a little bit further. So we have that factor, which can't be broken down, but this one can be split into, well, what two terms multiply to get 4x squared? 2x. 2x times 2x is 4x squared, and 1 is 1 times 1. Make one of them an addition, one of them a subtraction, and now you're done. That's going to happen, so you want to make sure you check each of your factors. Is it a perfect square? If it is, you can split it into two more factors. Okay, let's go. Okay, so the next one says that given that sine of x squared is usually written as sine squared x, and cos of x squared is written as cos squared x, factor these ones out. So no longer are the terms in here just x or y. We have sine functions now. So what I like to do is say, I'm going to use my substitution method with this one. So let's use capital A is equal to sine of x. So that means a squared is going to equal sine squared of x. So now we can rewrite this as 6a squared minus 7a plus 2. And we can do decomp on this. 6 times 2 gives me positive 12. I'm looking for two numbers that multiply to positive 12 and add to negative 7. Well, 1 and 12, 2 and 6, 3 and 4. 3 and 4 add to positive 7. What about negative 3, negative 4? Those multiply to positive 12 and add to negative 7. So I can split that up into 6a squared minus 3a minus 4a plus 2. And I can do my grouping and factor out. In the first one, I can factor out a 3a, and I'm left with 2a minus 1. And in the second one, I can factor out a negative 2, and I'm left with positive 2a minus, I took out a negative sign, so that switches it, minus 1. Shouldn't make videos at the end of the day. My brain is tired. So now we can rewrite this as 2a minus 1 and 3a minus 2. And what we can do now is substitute back in the variable that we set up there. So we know capital A is equal to sine x. So we can write this as 2 sine x minus 1, 3 sine x plus 2. And there's our answer. Same thing works for cos as well. Same process. Okay, we're going to try looking at what happens if x is a binomial. This is why this is so awesome, this substitution method, because you can see that we have 7 multiplied by x minus 3 squared minus 4 multiplied by x. Hang on, let me get rid of that. X minus 3 minus 3. So what you can do is say, well, let's let capital A equal x minus 3. So now this becomes 7a squared minus 4a minus 3. And we can do our decomp on it, right? 7 times negative 3 gets us negative 21. So we're looking for two numbers that multiply to negative 21 and add to negative 4. So 121, 3, and 7. 3 and 7 might work. So if we do negative 7, positive 3, that works perfectly. So now we have 7a squared minus 7a. We're going to split that. Plus 3a minus 3. We can do our grouping. Factor out, in the first one, we're going to factor out a 7a, and we're left with a minus 1. And in the second one, we're going to factor out a 3, and we're left with a minus 1. So now we have a minus 1 and 7a plus 3. So now things are going to get a little bit weird. Well, not weird, but there's a couple extra steps that we have to do that we normally don't do. So now I'm going to put this x minus 3 back in anywhere I see an a. So this one's going to become x minus 3 minus 1. And the second one's going to become 7 multiplied by x minus 3 plus 3. And now you have to simplify these. So in the first one, we have x minus 3 minus 1. So negative 3 minus 1 is going to make this x minus 4. And the next one, we're going to factor in this 7 so that I have 7x minus 21 plus 3. And then I can say, well, 7x, I can't combine with anything. Negative 21 plus 3 is going to give me negative 18. There we go. Those are the two factors right there. But it gets weird with those binomials. That's why this substitution works so well, because now you can get rid of it and then bring it back at the end. Maybe we'll go over this one in class. Remind me that we're going to go over that one in class, and we'll go over it. Cool. Thanks for watching. Don't forget to like and subscribe.